Okay, good morning. Let's have a class. And we have 4 labs already for microscope use. So today we're going to do something new. But on Thursday, we'll come back to do the microscope use. Okay? So what we're going to do today is lab, I believe lab 5. We'll talk about is transferring bacteria. Okay, now first concept is called aseptic technique. So what's aseptic technique means? Which means we transfer a bacterial culture into a target media without carrying unwanted microorganism. So say it very simple, we give you an example. If this is a broth, let's say this is a broth. Okay, I want to transfer an E. coli in there. It will be pure E. coli. 3+ pure E. coli. There is no airborne pathogen there, which is a pathogen from the air. There is no salmonella there. And there is no other microorganism. That's called aseptic technique. Okay? So before we talk about that, we want to talk about a little bit of bacterial medium. Now bacterial medium has a lot. In the lecture we'll talk about detail, but in the lab we'll basically talk about 3 things. So number 1 is a broth. So this is a bacterial broth. Very simple, liquid and yellow color, yellowish color. So it is a liquid. So what's the components are there? Beef extract. You have some peptone. You may have some tryptone and some sorbine, people say, or sorbine extract. Now, of course, it has a salt there, sodium chloride. Finally, of course, there's a water. Okay? And most of these ingredients, you will see a label which is called nutrient broth. It is a basic nutrition requirements for bacteria. So that is a broth liquid, which is very simple. Usually put in a tube, and it is actually looks like it is yellow color. And it should be transparent, by the way, if there is no bacteria there. So we call it aseptic. Okay, that's the first thing. Second, you will see a slant. This is a slant looks like. It's an agar in the tube, and there is a slope there. So this is, we call it agar in a tube with slope. So what it looks like? It looks like this. Okay? Now finally we have to do a zigzag streaks there. Now what is a slant for? Slant is for temporary storage bacterial culture. It is usually at 4 degrees Celsius, about like I would say 3 to 4 weeks maybe. Now, of course, before that, the bacterial culture has to grow at 35 degrees Celsius for usually 24 to 48 hours. Okay, so that's a slant. The last one is an agar plate. That is an agar plate. Okay, looks like it's a little bit wet because we come out of the refrigerator. Sorry. Look at here. Now, what it looks like, you can see it. It looks like a pudding. It looks like French pudding. But it's not a pudding. So Fanny Hesse has been generated the idea from the French pudding to have this agar. She's one of the research associates from Robert Koch's group. We learned in the lecture. So what is agar? This is a polysaccharide from seaweed. And this agar has to be melted at usually 50 degrees Celsius. So what of us, we can melted 50 degrees Celsius, solidified usually 35 degrees Celsius. And the bacteria can use it. So we say bacteria use it, but not eat it, which means will not break it. Bacteria will grow it. Okay. Now for the agar plates, what are we going to do? We will do a streak plating. After incubation, you will see some of those dots there. This is a pure culture. It is also a single colony. So what that means, a pure culture, it means a group of bacterial cell coming from a same mother cell. Okay? Now how many bacteria is this guy? It's not a one single cell. Not a single cell. You have to be careful. This is at least 10 to the 6 cells per ml density. That's a colony, okay? So there's some information we want to talk. So what we're going to do today, lab work. First thing first, it's very simple. You will get, right here, let's just get a bacteria, any of these bacteria plates you like. Okay, like last lab section. So we will pick a colony from the plates and aseptically transfer into a broth. So usually it's just use loop to transfer those here. And I'll show you how to do it. And this one will be incubate 35 degrees Celsius for 24 to 48 hours. And we'll see the bacteria grow, okay? Whether you grow it or not. The second thing, we will also get the same bacteria plates. It's a colony. And this colony will be streak plating onto slants. This slants we will do a zigzag streak. Again, this slants will be incubated 35 degrees Celsius for 24, 48 hours, and we hope we can see the zigzag marker. Okay, number 3, what we're going to do. This will be a streak plating today, but will be the first step of your take-home quiz. Okay? Streak plating. For mixed culture. So, how we do it? This is a mixed culture solution. 2 of you as a group, but everybody do it. So first thing is you're going to have to shake it to mix it. Then, using loop, we will to do is a streak plating. Streak plating, how to do it? Very intensive streak at the first conch. This is number 1. Then you have to flame the loop. Okay, flaming loop. Do a second streak. Second streak is less intensive. I use another color. Little bit less intensive, but it has to be from the edge of the first marker. Like this. Okay? That is the second streak. Then you have to flame your loop again. And then from the edge of the second streak, you have to do a third one, little less intensive. Then you have to flame loop again. So this is the third conch, and flame loop again. And from the third conch, you will do a final streak. So that's a streak number 4. Okay? That's a final conch. Now why we have to do the flame loop? The function of the flame loop is actually a serial dilution on solid agar medium. Because every time we flame the loop, the bacteria is killed. Then we, from the edge of the previous streak places, we actually diluted the bacteria. Okay, so this is what you're going to do. Now, you're using is a mixed culture, we mentioned. This is a mixed culture. So after you doing the streak plating, we will incubate 35 degrees Celsius, 24 to 48 hours. Ideally, you will see 2 different colonies there. So some colony could be large, some colony could be very tiny, small. Okay? For these colony, you first of all need to do a colony morphology description. And this is, we'll look at your lecture slides of last one from today's lecture class. And I will print it out for you on Thursday. So everybody will have it. May not be color. I have to say, we don't have a color printer anymore. But I will tell you which page we're going to use. That's the first step. Then the second step, all these colonies you're gonna have to using glass slides to do a gram stain. And in order to help you, I already asked the TA to make it, and I can tell you, one of them is E. coli. Another one is Staphylococcus aureus. And you use gram stain. You need to tell me which one is which. Okay? Because you already know what is E. coli looks like. What is Staphylococcus aureus looks like. So use the gram stain, make a smear, use 4 major steps of the gram stain, then underneath microscope, 10x fine specimen, 100x with oil immersion. You're gonna tell me 3 information of the gram stain, which is gram reaction, positive or negative, morphology. Now make sure this is cell morphology and arrangement. And I want you guys is to finish a lab report, which is in your lab manual, chapter 8. Okay, this will be together work with your bench partner. So everybody sit on the bench on the same side. 2 of you will be a group. And you do individually by yourself. And combine your results to see which one is better. Pick a better results and write a report. And following the instruction is on this page. And finally, it will be about 2 weeks from Thursday. 2 weeks from Thursday will be the deadline for the lab report. And it is 15 points. Okay? So you and your bench partner will work together. And I will mention it one more time on Thursday to let you know what you need to do, to remind you one more time. So idea is that today we do a streak plating individually, everybody do. Then the colony gonna grow on the incubator today, tomorrow. Then Thursday you will see 2 different colonies. First of all, describe the colony morphology. That need to use lecture slides. I will print it out. Then you use gram stain to tell me which one is E. coli, which one is Staphylococcus aureus. And the 2 of you work together, make 2 slides, pick the best one, take a picture underneath the microscope, and then finish the report. And you all work together. You only need to turn me 1 as a group. Okay? And I will remind you again. Now, something I want to also mention, next week, Tuesday, it is an open lab. Some of you are missing from previous labs, want to practice indole stain, simple stain, gram stain, you can come. Some of you did not finish on Thursday. Let's say Thursday you gram stain did not good, and you want to do it again. Then next week, Tuesday, is the time to make up. And next week, Thursday, there is no lab because this is our first exam, lecture exam 1. Okay, I want you guys fully prepared because the exam starts from 11 o'clock. If 9:30 you still have a class, it's not very fair for you guys. So the whole day, Thursday, will be focused you guys for do a very good job of the lecture exam 1. So that's a plan. Okay, next week will be open lab. Okay, after we talk about all these things, there is a very important thing I haven't mentioned. It is called label. And this is extremely important in the lab. And we have so many students. You have to do a good job of label. Otherwise, you will spend half an hour to find your sample. So how are we going to label it? If it is a broth, where we should label? On the top, yes, not on the bottom, not even in the middle. Because if in the middle, it's going to bother you to do the observation of bacteria. So on the top. Okay, so if it is a broth, you're going to label top of broth. Okay. Okay, what type of the information you need? Your initial, let's say my CS, you have your own. Your batch number, let's say batch number 1. And what type of the bacteria it is. For example, E. coli, you can write EC. And last one, you can write a day there. Okay. These 4 information you needed. Especially your initial and your batch number is needed. Okay, how about cilantro? Where should label? Right on the corner here. Not here, not here. Because we're going to see the observation of the cilantro. Okay, right on the corner on the top. So right on the corner on the top right here. Same thing. Your initial, batch number, bacterial name, and the date. Okay, your initial is not CS. I mean, once upon a time, I was right to say everybody writes CS and cannot find it. It's your own initial. I just gave you an example. Okay, if you're Mary Nugent, then it will be M, N. It's up to you. So, okay, so that's you decided. But the bottom line is you can be recognized by yourself. Okay, last big question. I have an agar place. It's agar. Now, by the way, this container called a petri dish. Is that right? Richard Petri created. It's round shape, and it saves the material and the surface area. There is a lid, there is a bottom. Where we should label? Always is labeled at the side of the bottom, not on the lid. Why? If the lid is gone, you cannot recognize it. That's a very simple exam question, usually true or false. Agar media always label side of bottom, because we want to see the colony. Okay, you're not going to be just labeled middle right here. Always side of the bottom. Let's say your initial, batch number, bacterial name, and date. For example, 23. Side. Now, sometimes when you work in the lab, you could do only edge. That's fine. But never on lid. Because if you're on the lid, what's going to happen? The lid is gone, you cannot recognize it. So this is very important for the label. Especially when we go to next month, we're going to go ahead to do biochemistry reaction. So one lab, we may have 3 or 4 or 5 biochemistry tests, and the bacteria need to grow in the tube, and in the next lab, you pick it, then do the confirmation test, you have to recognize it is yours. And by the time, the label is extremely important. Okay, the bottom line is that you know what you are doing, it can be recognized by yourself, it is yours. That's a function for the label. Okay, very important. So this is what we have. Next, same thing. I want everybody coming to right here. I'm going to show you how to do it. Okay. Okay, I'll use this lab as an example. And we also need a broth. So I have a broth right here. And I also need a Sharpie pencil, and I need a gloves. Can I have a gloves? Somewhere. Thank you very much. Okay, so this lab is simple. It's not difficult. You may be finished in about 5 to 10 minutes, but I hope you do a good job, because it is first time you do transferring bacteria, and I don't want it to be looks like horrible. The place looks like. Okay. And we also need some paper towel. I want to tell you what's the story behind it. First thing first, check this one is working. This is flat. Okay, make sure this is good. Check to see. Do I have the hockey stick? Because see, that doesn't work. No fire. Do I have a new one?
It's not.
Thank you very much. We'll see. Too much. Okay. Adjust a little. Okay. Make sure this is working. Okay. You can turn it off. Okay. Don't worry about right now. But make sure it's working. Okay. Now we're gonna do the label. First thing first is a brush. This is usually come out of the refrigerator very wet. So use a paper towel to clean the surface a little bit. Now you're going to label on the top. What we're going to do, CS and batch number 1. This is E. coli, and this is 0903. I don't know what's the date. I'm just writing 2023. Okay. Second one. Slant label right here, okay? So CS number 1 EC 090323. Right on the top. Same thing, right on the top. Okay, agar plates, this is extremely important. Make sure it is dry. Okay? You can also do inside, not that wet, because those liquid is bothers you. So make sure it is dry. And at the bottom right here, you're gonna write initial batch number. And this is a mixed culture, so we write a mix. This is not E. coli. Remember the mixed culture. And date is 090323. Okay, all these things ready. And we also need a plates, so we get a plates. You can use the older culture. Okay, so let's do it. Now back, turn on the fire. This is called a Bunsen burner. First of all, aseptic technique, we flame the loop. Make sure it is completely red, okay? And not like this. Okay, completely red, little bit on the top. So what we do, first to do broth, easy. When you have a plate on the side, you hear the zzz voice, cool down. So you pick some colony there, okay? After you pick the colony, little finger, take the cap out. Flame. Then go in, shake a little bit. Come out, flame again, then go back. Little finger. And this need to flame. Okay, lots of people's mistake I want to show you. This is not correct. Then do it. That's not correct. Because the bench has a bacteria, this cap already touched. You put in there, maybe the bacteria from the bench gonna be there. That is not following the aseptic, because we don't want to carry on unwanted airborne bacteria. Okay, so that's the first thing. Second thing, we don't use too often, but let you practice. Flame the loop again. Okay? You put on the side, hear the voice, and pick the colony. What you do, little finger open, flame, then you go down a little bit on the bottom, not touch the liquid, then do a zigzag. This is a slant for temporary storage. Flame again, put it back. Okay? Now flame the loop. That's very important because next one, we're going to do a mixed culture. Okay, so flame it. Before we do the mixed culture, start from today, anything liquid, you're not going to just go ahead to get it. The first thing first is shake. Like this, around 15 seconds at least. But you know, in the lab, we have something, put it there, it's like a vortex color. Is that right? We don't have it. So some of you work in the lab, other the chemistry lab, biochemistry lab, so shake. This is a very traditional. I want to put every bench a vortex at least, sometimes. Okay. You see the bacteria at the bottom, okay? Now what we do? This will be the agar plates you can put on here. Okay, so flame the loop again. Make sure it's all killed, the bacterial sterilization, a little bit on the top, cool down a little bit. Flame the loop, and then you can cool down on the side, then go inside. You hear the voice. It's okay, it's not going to kill bacteria. Okay, then go here. Open, one hand open, then you do very gentle, intensive streak on the first cartridge. Flame the loop. Cool down on the side, then from the edge of the first streak, do a very gentle second one. Then flame the loop again. Cool down on the side, and from the edge of the second one, do a third. And then flame the loop again. Cool down, then from the edge of the second one, third one, do a fourth. That's all. You can see there's a marker there. Okay, then put it here. And then you flame the loop again. Finally, turn off the gas. These two, you're gonna give it to TA, we will do the incubation. We want to see the bacteria grow, which turns turbidity on Thursday. This will see a zigzag marker. This one we're going to look for, there's a single colony there, and there is a good colony, we're going to do a colony morphology. Okay, I always made one as a backup. If somebody failed, you can use mine. Last thing, when we put the plates onto the incubation, we don't do like this. We don't stack like this. We always flip it over because there's a little bit of condensation. So after streak plating, we put it here on the bench about 5 minutes, then we flip it over. Because otherwise the liquid condensation will damage the agar surface if you put it in the refrigerator or put it in the incubation. The incubation usually is 35 degrees Celsius. Okay, that's the last thing I want to say. Now everything is good, so go ahead to do it.